All right, everybody, welcome to the video here for the practice lesson or practice problems on the law of sines. First off, I do want to apologize for the background noise. My dishwasher is going, so just kind of try and ignore that if you hear it. Not sure if you do or not. All right, so using the law of sines, so one of the things that we know about the law of sines is the law of sines is any side of the triangle divided by the sine of its angle is equal to another sine of a triangle divided by the sine of its angle. Right? So if we're looking here, we're looking for matching pairs. So one of the things I notice, I see a matching pair right away in this first question, the angle of 50 and the side of 23. But the side of 101 would give me this long side down here. I don't want that long side. I want this side. So I want to know what this angle is, so it becomes the matching pair to x. Well, luckily I know that all triangles have 180 degrees, so if I subtract 101 and 50, I get 29 for my remaining angle there. So I can set up my ratio. So my ratio is going to be x over the sine of 29. You'll probably remember me saying in the last video, only use the law of sines if you have to. So only use the law of sines if you don't have right triangles. If you have right triangles, try and use the regular SOHCAHTOA trigonometry that we've been talking about. So if we do some quick algebra, just like we did in the previous video here, we could get to an answer. I'm going through these a little bit quicker than I did in the last video because you should have watched the last video, right? So if you're still struggling with this and you're just having trouble doing the algebra part of it, just look back at that last video and hopefully it all makes sense to you. So for that first question, we're getting 14.6. All right, so let's take a look at number two. Number two, the same situation happens. So I have a matching pair, angle and a side, but the angle here, which would match the variable side, is missing. So we got to do 180 minus 71 minus 44. So that would give me an angle here of 65. So what are my ratios? So my ratios are x over the sine of 65 is equal to 12 over the sine of 44. Now this one says round to nearest hundredths, so we just got to be careful here. That's different. So we have x sine of 44 is equal to 12 sine of 65. Divide both there by sine of 44, and we should get to our answer. 12 sine of 65 divided by the sine of 44. Just watch your parentheses, and we get 15.66. All right, moving right along. All right, question 3 says use the law of sines to determine the length of both sides of the missing triangle. So I'm going to label one of them x and one of them y. If I want to find both sides of the missing triangle, I definitely need to know all three angles. So if I do 180 minus 70 minus 68, I'm left with 42. So then we're going to set up two different proportions, one to solve for x and one to solve for y. So x has a matching pair with 42. 70 and 37 is our matching pair we want to use a lot of. So I have x over the sine of 42 is equal to 37 over the sine of 70. So if we solve that, right, cross multiply, so we have x sine of 70 is equal to 37 sine of 42, divide by the sine of 70, and we get this ratio. Again, I'm going through this fast. If you're confused, go back at the previous lesson. So if we type that in our calculator, 37 sine of 42 divided by the sine of 70, we wind up getting, it says nearest thousandth, so 3 decimal places, 26.347 for that missing side of x. Well, if I want to set up a proportion to solve for y, it would be y over the sine of 68. So there's my matching pair. And I want to use the same ratio I used to solve for x because 37 and 70 were given. I don't want to use this decimal. A, I rounded it, and B, I found it, so I might be wrong. So I don't want to use something that I might have that's wrong. So we want to try and use everything that they give us whenever possible. So if we do some cross multiplication, some division of the sine of 70, we get a y value of whatever that comes out to be in our calculator. And again, nearest thousandth, so 3 decimal places, 507. So 36.507. Not too bad. All right, let's take a look at the last one. So it says using any trigonometry to determine the value of x rounded to nearest tenth. So this is a question where we actually don't want to use the law of sines, right? Why? I see right triangles, right? So that altitude, that blue dotted line, I'm going to make y. And I'm just going to look at the triangle that's larger. This is my given angle. This is the opposite side. This is the adjacent side. So I can use the tangent of 39, the tangent ratio, to find the value of y. Multiply both sides by 38. 38's cancel. So I have y equals whatever 38 tangent of 39 is, which is 30.772. Notice I'm not rounding to nearest tenth there because that's not my answer. I don't want y. I want x. But now if I focus my attention to the other triangle, so 60, x, and this new length of 30.772. It's another right triangle. I know that because altitudes make right angles on both sides. Now, unfortunately, I have to use this answer that we've already found, but sometimes that's just what we have to do. So this is the opposite side. This is the hypotenuse side. So we're going to use sine. So the sine of 60 is equal to 30.772 over x. Multiply both sides by x. Now we have x sine of 60 is equal to 30.772. Divide both sides by the sine of 60. And whatever that comes out to be in our calculator is my answer, 30.772 divided by the sine of 60. If you have a new calculator, you can even just scroll up to the previous answer there, so you don't even round at all, but you should all get the same answer here of 35.5 for x. Hopefully this video helped. All right, you got one more lesson, I think, after this before we start reviewing for your test, so you can even start working on those study guides and things like that as we keep moving forward. All right, and I'll see you all soon.